This is the second recording for week 3 on goniometry. Goniometry is a technique of human joint measurement. Gonia means angle in Greek, and metron means measure in Greek. The purpose of goniometry is to screen for abnormal joint movement and to find out the patient's willingness to move. Except for range of motion in the transverse plane, the starting position for range of motion is the anatomical position. This permits a complete range of motion measurement, and the PTA stabilizes the proximal joint segment to isolate the joint that's being examined. Here you see some examples of goniometers. Plastic universal goniometers are available in different shapes and sizes. Some goniometers have full circle bodies, whereas others have half circle bodies. The 14-inch goniometer is used to measure large joints, such as the hip, knee, and shoulder. 6 to 8-inch goniometers are used to assess mid-sized joints, such as the wrist and ankle. The small goniometer has been cut in length from a 6-inch goniometer to make it easier to measure the fingers and toes. The metal goniometers that you see on the right come in different sizes. The ones shown have half body circles, but they can also have full circle bodies. The smallest goniometer is specifically designed to lie on the dorsal or ventral surface of the fingers and toes while measuring joint motion. Some of the goniometers have a cutout portion on the movable arm, whereas other goniometers have pointers on the moving arm to enable the reading of the scale on the body of the goniometer. Here you see more figures of goniometers. If you look on the left, you can see the parts of the goniometer. First, there's the body, and in which you have the fulcrum, which is placed at the axis of motion of the joint. The stationary arm is usually the proximal arm, and it is attached to the body and does not move. The movable arm is also called the distal arm, and this is the part that you move as you measure range of motion. On the right, you see a universal goniometer that forms a half circle. The stationary arm is an integral part of the body of the goniometer. The moving arm is attached to the body by a rivet so that it can be moved independently from the body. In this example, a cutout portion, sometimes referred to as a window, is found in the center and at the end of the movable arm. The windows permit the examiner to read the scale on the body of the goniometer. The body of the goniometer may be either a half circle or a full circle. The selection of goniometer is determined by what you want to measure. The size of the goniometer is very important for accurate measurement. The examiner here is using a full circle instrument with long arms to measure knee flexion range of motion. The arms of the goniometer extend along the distal and proximal segments of the joint to within a few inches of the bony landmarks, which are the black dots, that are used to align the arms. The proximity of the ends of the arms to the landmarks make alignment easy and helps ensure that the arms are aligned accurately. The small half-circle metal goniometer is a poor choice for measuring knee flexion, as you see in the bottom picture, because the landmarks are so far from the ends of the goniometer's arms that accurate alignment is difficult. Inclinometers are gravity-dependent measurement systems, and each of these gravity-dependent goniometers uses a weighted pointer or bubble to indicate the position of the goniometer relative to the vertical pull of gravity. All of these inclinometers have a rotating dial so that the scale can be zeroed with the pointer or bubble in the starting position. As I said before, inclinometers are gravity dependent, and they use the gravity's effect on the pointers and the fluid levels. Sometimes they're easier to use because they do not have to be aligned with bony landmarks or centered over the axis of motion. The proximal segment of the joint being measured must be positioned horizontally or vertically before taking the measurement. A note is you should not use goniometers and inclinometers interchangeably because you may obtain slightly different results. The purpose of finding anatomical landmarks is to accurately visualize the joint segments when you're measuring. Here the examiner is using a greased pencil to mark the location of the subject's left acromion process. Note that the patient's clothing has been removed so that the bony landmark can be easily visualized. The examiner is using the index and middle fingers of her left hand to palpate the bony landmark. Usually the stationary arm of the goniometer is aligned parallel to the longitudinal axis of the proximal segment. Here are a couple of pictures that you can see. The first one on the left, when you're using a full circle goniometer to measure range of motion of elbow flexion, the stationary arm is usually aligned parallel to the longitudinal axis of the proximal part, which is the subject's humerus, and the movable arm is aligned parallel to the longitudinal axis of the distal part, the subject's forearm. However, if the arms of the goniometer are reversed, you can still get the same measurement. In the second picture, when the examiner uses a half-circle goniometer to measure left elbow flexion, aligning the movable arm with the subject's forearm causes the pointer to move beyond the goniometer body, which makes it impossible to read the scale. Therefore, reversing the arms of the instrument so that the stationary arm is aligned parallel to the distal part and the movable arm is aligned parallel to the proximal part causes the pointer to remain on the body of the goniometer, enabling the examiner to read the scale along the pointer. Just a note on hypermobility. On the left you can see that the subject has excessive elbow flexion. The subject has 20 degrees of hyperextension at the elbow. In this case, motion begins at 20 degrees of hyperextension and proceeds through the 0-degree position to 140 degrees of elbow flexion. The second picture is another example of hypermobility, and this is genu recurvatum. The measurement will be the same as with elbow flexion. Finally, we're going to show range of motion measurements and the results of changes over time. This pictorial chart records the results of flexion range of motion measurements of a subject's left hip. For measurements taken on March 18th, note that the 0 to 73 degrees of left hip flexion occurs. For measurements taken April 1st of the same year, note the 0 to 98 degrees of left hip flexion. So you can see that this depicts the improvement in hip flexion over time.